Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
We've now have generated our region of interest, which is in this case North Korea, and we've went to the Google Earth catalog, Google Earth Engine catalog, and we, based on my 5 criteria, identified 4 data sets that we could that we need to explore. So that's going to be the function of this video tutorial, is to look at those 4 data sets and see whether they actually, whether they can work for what we want to do. So that's going to be the purpose. On this point, please, boys and girls, 370 subscribers, we need to get that up, please. Let's get that up. Press those buttons. We need to get that number up. So yeah, in advance, many thanks. So as I said in a previous video tutorial, we used the browse by tags functionality within the catalog to identify all the databases, data sets that's available that possibly we can use. And then based on my 5 criteria, we selected or identified 4 possible data sets. And then we bring them into our script, our Google Earth Engine script. And here they are. So the purpose of this video tutorial is just to basically first glance how these data sets look like, what's the ins and outs of them, etc. So that's basically what we're going to do for this video tutorial. So the first one that we're going to focus on is the SUMI NPP VS data set, this one here. Okay, so let's go and have a look at that data set. What is its characteristics? Okay, so let's go into our dataset catalog. We're going to copy and paste it into our search function or search bar, and we're going to search for it, and here it is. Let's open it and let's have a look at it. It's 23 to 2024, so unfortunately it doesn't have an history, but it is up to date. Its spatial resolution is very good. I think it's on a monthly basis, maybe even more. And its band that we're going to work with is bright TI4, which is in Kelvin 250 to 400. It measures the brightness of a fire pixel. Okay, so that's the detail of it. So let's have a look. Basically, I brought it in. I said, okay, there's my data set. It's an image collection. So there's multiple images within that duration. And we select the band, which is at bright TI4, which is bright TI4. We can also do bright TI5. Not sure what the difference of the two would be, but anyway, we'll have to look at it. Then my filter date, then basically in the entire image collection, 23, 24, 6, 20, yeah. So basically we are bringing up the entire collection, and we are reducing it by using the median reducer, and we clip it to our region of interest. This is a standard code, the one that we've been using most of the time. Nothing much to it. We have our data set, it's image collection. We select the band that we want to display. We create our time frame, and we reduce it by, in my case, a median. I always tend to reduce it by the median, and I did 1 or 2 videos, tutorials on that way in the beginning. I can't remember which one, where we looked at the mean compared to the median, and then we clip for our region of interest. And here I didn't use the clipping tool. This one here I used the normal clip Roy, but we can use the clipping tool as well. Remember, the region of interest is not the styled map image. It is the North Korean, the one here. Okay, so just bear that in mind. And then we generate our visualization parameters to 280 to 400, and then it is from yellow, orange, red, white, dark in terms of intensity. Remember, it is we measure the brightness, so that's fire intensity. From 280 to 400 Kelvin, we can include a script here to convert that into Celsius if we need to, if we want to, and then we display it. So let's first just go through them before we display them or we visualize them, because these things do take a bit of time to load. So, well, let's have a look at it. This is how it looks like. Okay, so that's how it looks. I don't want to zoom too much in at this stage because it's going to struggle to load. So remember, dark red is, so these are high intensity fires, and then yellowish is low intensity fires. Interestingly, it's seemingly randomly distributed throughout the country itself. It doesn't seem to be clusters, although there seems to be a high propensity of fires there, one there, there's another one there. So there seems to be 3 areas that seems to be prone to fires, high intensity areas. And we can do a bit of work on that a bit later. So that's the first one. It's a polygon. And it's showcased locations with fires. Let's have a look and see. Brightness, description, probably based on compared to satellite, such a fire detection. Okay, relative small areas, so that's good, as well. Improved mapping of large perimeters, well-suited views of support of fire management, near real-time alert system, additional information. Okay, so that's brilliant. So it's daily. I think it's daily. Yes, it's daily. So that's, yeah, very, very good. So that is the VIRS data set. Okay, so the next one we're going to do is use the firms. Let's click this on. So long. Okay, there it goes. So this is the firms. Let's go and bring up its credentials. Let's search it in, and we're gonna search it. Okay, so fire information and resource management. So that's 2000 to, so that's good past history, and it's updated. It is 1000 meters, so it's not as space temp low resolution, and that's brightness of a fire pixel. So that's also like intensity, also Kelvin. So very similar to, except the resolution is much lower, 1000 meters. Okay, so that is that. So this is how. Okay, so we it's again an image collection. We bring it in, we give it a filter date, and I've again filtered it from the beginning of the data sets to the end. So for the entire image collection, 2011. So I brought it in for the entire collection. Then we obviously select the band for it, which is T21. Let's go back, band T21. Not sure what T21 means, but anyway, that's the band. And again, similar, we create a median image and we clip it to our region of interest. We generate our visualization parameters. Why are we not? Let's use the same. Let's use the same visualization parameter, palette. Just for, yeah, so that makes sense. Let's keep it that. It's the same. 325 is the minimum here, 280, 400. So it's a bit 325, 400. Come on, where is it now? 280, 400, 325, 400. So pretty much the same. And that is how that data set, let's unselect the VS one. That's how it looks. It's obviously very, very different because it's such a long period. So it looks like the whole place is on fire, but remember, this is a median image over a 24-year period. So it obviously it's not all the fires at the same time. Could be, as I said, a fire that happened 20 years ago, but it will be included because it would have recorded the fire. So obviously that's because of the time frame. That's why it looks so. But still dark red. So fires that are of high of intensity. So that's the Fire Information Resource Management System database. So we've got the two. This one looks quite good, and it's got a long history. I'm not sure whether it's daily, and the spatial resolution is not as good. You can see spatial resolution being much bigger. So that is the second data set. Two down. Okay, so now let's go and have a look at the third one, which is the modus burned area. So let's activate that in the meantime. Let's take that out. So that is burned area monthly. So let's have a look at the ins and outs of that data set. So we're going to go copy. Let's go search. And we're going to press enter. Okay, let's go and have a look at it. Burnt area monthly. So this is monthly. 2000 to 2024. So that's again quite good. It's monthly. So fires are typically don't last on a monthly basis, but nonetheless. So this is the burn day of the year, possible value. So that gives you the day of the year. So it should give you a value of 0 to 31. 500 meters, which is fairly good in terms of the spatial resolution. Let's have a look. This is how that one looks. It shows you quite a bit of burnt activity around this particular area here towards South Korea. So that gives you from 30 to 341. So that's your days. Okay, we also clipped it for our entire image collection. Burn date, our band, median again, and clip for our region of interest. So that's our standard code. We just basically changed the variable, the date, the band. So that's the only three things that we changed. Obviously, we also changed the visualization parameters. So let's do the same here. Let's do the same color scheme or color palette. Let's do the same. Let's keep it consistent. Let's keep it consistent for the sake of consistency. Looks similar. Okay, there it is. And so that is how that one looks, that data set. That is how it looks. You can just visually from this see that it's got much higher spatial resolution, more spatially granular than the previous one. You can just see the size of the pixels are smaller. That's what we mean. So let's have a look at the last one. So this is the last one that we're looking at, which is the terrathermal anomalies and fire daily. So let's copy its identifier. I'm going to go to search, paste it in. Let's see how that one. Also 2000. So except for the first one, the last three ones, the subsequent ones, they're all from 2000 to present. So they must be using roughly the same. Satellites. They're all from 2000 to 20. Yeah, so they roughly all start at the same period, which is interesting. They present the data a bit different, but they all have the same period, the same starting period. So that's good. This is also daily, not as good spatial resolution, and we're looking at max FRT, which is radiative power. So this is also like intensity. That is megawatts, I presume 0 to 2008. Okay, it's a scale, so it's actually not 180,000. It is actually only 18,000. Because we have to remember the scaling value. Let's see how we go. See what that looks like. So there it is. Bands. I don't know what. Oh, this is the bands that it selects. It doesn't have a color scheme. We need to maybe bring a color scheme. It's selecting max FRP. Max FRP. And then why is it, what is fire mask in fire mask? I'm not sure. Oh, there's fire mask, the confidence of the fire. Okay. So it also looks at the confidence of the fire. And then it presents it the image or the map. It doesn't have a color scheme, so we need to bring in a palette here. Let's do the same one. Let's do exactly the same one. So let's also bring it in there. And there it is. What else am I missing? Okay, and that's how it looks. You can see, unfortunately, because we haven't changed the color scheme, it is basically just black. So I want to see if I can use my inspector. Let's save again. Remember, boys and girls, always remember to save. So we've got that little star. Okay, there. Let's quickly have a look and see. Now, the inspector, I'm not sure where it's going to be a miss and hit and run. Let's click on that one there. North Korea, okay, so that's not, okay, so there is 344, is according to the viewers. The firms 315, so remember that is Kelvin. So there's a fire, 344, 315, burnt area. No, there was no burnt area image. Let's have a look at the mask. So there was a fire was detected by the viewers. By the firms, no fire was detected by the burnt area data set, and then we're just waiting for the fire, the last one to, did we go to the, yes we did, which is between 0 and 18,000, not 180,000 because of scale. So let's have a look and see, it's still struggling. Okay, so there it is 5, fire mask 5, what is fire mask? Fire mask 5, confidence of fire, is a value of 5, and then a max FRP, it gives as 758, which is on the lowy side, compared to the maximum. So sample 0, Q&A 6, that's Q&A, let's have a look and see Q&A, pixel quality indicator 6. Sample position of fire pixel within scan is 0. Okay. So it also presents this information there. But yeah, I don't want to zoom in too much because, well, let's give it a go. We'll have to give it a, because it does, okay, let's activate all of them first. Let's move the image slightly. And let's zoom in a little bit. It may take quite a bit of time now, unfortunately. But let's see. Okay, so bottom line is we have identified our data sets in the catalog, Earth Engine catalog. And now we've brought those data sets into our script. And so we brought it in. We give it the necessary parameters, meaning we select the band, the relevant band. We select the dates and the reducer, and we clip. That's the parameters. And then obviously we generate our visualization parameters and we display it. But as you can see, it does take, especially the fire mask one, takes a hell of a lot of time for whatever reason. But I mean, it's quite a big area, so one would assume there would be some difficulty in loading our images. You can see there, let's go, you see, so that's the viewers. You can see that's how that looks. Let's take our North Korea out. So that's our viewers fire detection, and it's a median image, and it's found, and it's based on daily data from 23 to 24, and we know that yellow is low intensity fires, dark red is high intensity fires. So that's how that looks like. Let's look at our firms. Let's take this away. You can see that's now obviously much more red. You can remember, because it's over a 24-year period, so obviously it will have a much wider coverage on fire detection than if it was only for the last week or so. So that's how that looks like. You can see the spatial resolution are definitely worse than the previous one in that I think this is 1,000 compared to 100 or something. So let's take that one. It does take unfortunately a bit of time. Burnt area. Now this is okay. There's our burnt area. You can see this is the fine granular spatial resolution burnt area. You can see it's very small. And then the last one is the fire mask. And this one struggles to load for whatever reason. I think maybe what we have to do is just take the bands away and only run the fire, only that band. Maybe it will generate a bit quicker. So let's click run. I doubt it's gonna generate any images now, simply because last time it took about an hour for it to start generating images. Okay, so there is the VS. The VS ones are generating quite quick. The others might take a bit of time. So but I think you get the idea. We've brought them in. So now let me just open the editor's script code window a little bit, make it a bit bigger. Okay, so I think we've got the gist of it. We've got the foundations now to start working from. We brought in our region of interest, we've identified, we clipped it, etc. So we sorted with our region of interest, we're happy with it. We've identified 4 data sets that talks to fire detection and indicates whether there were fires or not. So we've got the 4, we've brought them in, we generated an image for each of those, or a median image for each of those 4. And we've went through that. And we've tried to create a color scheme that's consistent through all 4 of them. So let's save. Okay, so now we can start with our more in-depth work. Okay, now we can start with our in-depth work. And we're going to try to use all 4 of them. We're not going to work just only one of them, simply because they do seem to complement one another. So let's end the video for now. I think because this is going to take ages to load. As I said, it's still trying to load. So let's park it there. We'll come back when all the videos are loaded, and we're going to see what else we can do with this. See what else we can generate from this data sets. But yeah, so we've identified our locations that have recorded or experienced fires over the last 20 odd years. So with that said, yeah, thanks for joining me. Thanks for your support. Your comments are always appreciated, and I'll see you on the other side.